Hey guys, today we're going to be working with radicals. I'm going to have videos on how to simplify, multiply, divide, add, and subtract. So once you're done with this one, make sure you click on the rest. Make sure you subscribe to this playlist so that you can get all of the videos on radicals and know how to do everything for this unit. Thanks for watching. The example we're going to start with for simplifying radical expressions is we're going to look at these four problems first. And what we're going to do is we're going to try and match each problem with its simplified form, kind of using educated guesses, what we know about radicals and exponents first. So if you're doing this, I'd like you to stop, press pause, and try to match them on your own, and then press play to go over them. So now that you've made some guesses on your own, the first one we're going to look at is 1. So on number 1, we have this 3 here, and we know that some number times itself 3 times gives us -8. So we know that that number is going to be -2 times -2 times -2. 3 negatives, keep it negative. 2 times 2 times 2 is 8. The second problem here, the only answer that has a decimal in it is A, so we know that that one's going to be A. And then if we want to check, we take 0.2 times 0.2. 2 times 2 is 4. And since we have 1, 2 places after the decimal here, we need to add in a 0 to make sure it's consistent in our answer. For this one right here, kind of the obvious one, if you have an even root and a negative inside an even root, that negative is always going to turn into the letter I. So the only one with I is letter B, so that one's B. And then remember, the only way to make 1 by multiplying a number an infinite amount of times is to multiply 1 by itself. So 1 times 1 times 1 times 1, 4 times gives us 1. And then this last one, if we're squaring and we have a square root, those are inverse operations, so that means they cancel each other out. So 4 is going to be letter D. For simplifying radical expressions, the method that I'm going to give you using the OMG is going to be for any radical expression. I wanted to come up with a way to do this. Doesn't matter what the problem is, you can use this for anyone. So the first thing that needs to be observed is the radical with its index. And the index is that small number in front of the radical kind of attached to the top of the outside of the radical. Our mission is going to be to simplify, which means you're trying to remove anything you can from inside the radical to outside the radical. And then our game plan for doing this is to first make a factor tree, then use your index to determine how many of that number or variable you can take out. So here's our first one. So when we take 16x to the 8th, we break it down into its factored form. So 16 breaks down into 4 and 4. And 8 breaks down into... Okay, so once you're here, you might be asking why I didn't take the 4s and break them down into 2 and 2. But when we're square rooting does not have an index, but the index is always 2. So for square roots, we're always looking for pairs. So it doesn't make sense to break 4 down further if we already have a pair. So here's kind of the way to simplify square roots. This is the way I teach my kids, or I guess any root. The index tells you how many can come out. So it's kind of like you're going to a party or a restaurant or whatever way you want to think of it. And the index tells you how many people you have to be seated at that restaurant. So for this one, it says I have to have pairs of 2 to be seated. If not, I'm going to stay home. So the radical represents your home. So I have a pair of 4s, so that means the 4 is going to go. Then I have 1, 2, 3, 4 pairs of x's. So I represent that by x to the 4th. And since everything had a pair, no one had to stay home. Everyone got to go. So this is your answer. The next example we're going to do is a to the 6th, b to the 9th. So this one, our index is 3. So that means we're looking for groups of 3. So I'm going to take my a's and I'm going to break them up into 6 a's and then my b's into 9 b's. So like magic, now they all appear. We're going to be looking for groups of 3 since our index is 3. So I have a group of 3 here. and I have a group of 3 here. So that means they get to go. Just put that 3 there. That means they get to go out. So since I have 2 groups, I'm going to represent that as a squared. Then my b's, I have 1, 2, 3 groups of b's, so I'm going to rep that as b cubed. And I have nothing left inside, so that is my answer, a squared b cubed. What you hopefully are noticing here is that if you take this power and divide it by the index, you get this number. So 6 divided by 3 is 2, 9 divided by 3 is 3, so that's kind of the shortcut or the easier way, I guess, to do them. So for this one, that rule is helpful because we don't necessarily want to write out 12 x's and 16 y's. That would take forever. So I'm going to do x 12 divided by 4, since 4 is my index, y 16 divided by 4, and then 12 divided by 4 is 3, 16 divided by 4 is 4, so again, that is my answer for that one. And then the last example I'm going to do is this one right here. So for this one, if I have a negative, your negative always gets pulled out as an I. So let's just put that out there so we know this negative has been taken care of. It becomes I. And then 81 is going to break down into 9 and 9. So right there I have a pair. Don't break it down any further. So I'm going to put 9 here. And then x to the 4th, that means I have 4 x's. So that means I have 2 pairs. So that becomes x squared. Now, something to remember for these problems is that when you're square rooting and it's an even root, so 2, 4, remember there's a 2 for square roots, you can do your plus or minus. So some teachers are going to want you to do that plus or minus to remember that it can be positive or negative. Or sometimes people write it like this with an absolute value symbol around it. So just so you can see, the plus or minus represent the fact that for even roots, if you do a plus or minus, then you get both sides of the equation because it could be positive or negative and still end up being correct. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.